Hello and welcome everybody to today's webinar presented by Hexagon Manufacturing Intelligence. Thank you for being with us today. I'm your moderator, Christina Fugis with Mold Making Technology, and today's webinar is Demystifying Flow Analysis, Advancing Plastic Injection with Smart Manufacturing. Our presenter is with us today is William Polis. He is the Technical Sales Specialist for Hexagon. All right, before I toss it over to William, I want to let everybody know that you can ask questions during the presentation by typing them in the Q&A tab on your screen. And then when we're finished with the presentation, we'll try to go through each and every one of those. And lastly, we are recording this webinar so you can listen to it later online. Now over to you, William.
Oh, thank you. Hello, everyone. I'm William Polis with Hexagon. I am a technical sales specialist with the production software Mold and Die Group. Welcome to the webinar about VISI Mold Design software with the flow analysis module. We will show how the flow analysis fits within the complete design through the manufacturing workflow for plastic injection molds. From the filling analysis through the prediction of the final shape of the part, including thermal analysis. Like Christina said, this webinar is being recorded and will be made available after the event. Feel free to post questions in the Q&A area, and at the end of the webinar, we will try to answer as many as possible. In our agenda today, we will focus on the following: design workflow, simulation challenges, VISI simulation and analysis capabilities, VISI flow analysis, VISI warp analysis, VISI thermal calculations, and of course Q&A. Since we have a lot to get covered, let's get started. The VISI end-to-end solution is built around a workflow that a company must face when engineering or building a tool for the plastic injection mold. This flowchart comes from a discussion with several customers on their approach on how they're trying to solve problems. The steps, on average, are those of some typical customers, even if the order is slightly different. Today, we're going to focus on the FEA portion, shown in green up here. More in detail are the categories of the processes which we will expand on in this presentation. So filling validation, runner optimization, final shape prediction, and thermal analysis. Plastic injection design workflow. How can we help mold makers? This flow chart, which illustrates virtually the entire process, explains how easy VISI Flow enables us to overcome the costly traditional trial and error approach. We can see that all the areas of the molded part can benefit from the optimization of mold tool design and mold processing parameters. Tool designers, mold makers, and molders will all benefit from using Hexagon's innovative technology for injection simulation to achieve cost-effective and reliable mold designs and optimal molding conditions. VISI Flow is a unique prediction tool, ideal for pre-production and post-production analysis and concurrent engineering of injection molded plastic components. The possibilities provided by the software range from the automatic modeling of the part, which cuts modeling preparation and calculations times, to accurate filling simulations, warpage prediction, and engineering of the mold water system. VISI can assist with the workflow. VISI FEA for plastic injection molds can be viewed at several stages within the workflow. At the initial stage of reviewing, VISI flow analysis can perform some quick estimates with different scenarios of possible different gating locations. This could even help at the quoting stage. At the second stage, when most of the design is finished, creating an FEA to include warp analysis to see if any design adjustments are needed before the final design. At the third stage, with the final design finish, creating a complete FEA to include filling, holding, shape, and thermal analysis to verify the design is good to go for manufacturing. An additional FEA can be performed when the part is removed from the press, then scanned into VISI. using Hexagon scanner and compare it to the original model using VISI reverse module. The VISI Flow FEA solution overcomes during the process the costly traditional trial and error approach. This is very important to be able to predict instead of react after encountering some problems. Challenges and solutions. Let's briefly see the challenges mold makers and molders are facing. The injection mold represents a significant investment in developing products. The use of technology to streamline the process will illustrate what mold makers can do to achieve success. In fact, VISI software solution develops and validates the molding process to achieve high quality parts that meet the molding specifications. Material selection. Materials also play an important role in increasing the longevity of components and lowering the weight of various parts to improve the overall fuel energy efficiencies. Consider all these aspects. We believe that the software is the key to improving the plastic part and the injection mold designs, as well as the whole manufacturing process, resulting in the design quality and accuracy of the parts from the very beginning to lower cost and future savings. Gate positions. The positions of the gates are very important to properly fill the part. Runner optimization. It is also important, the optimization of the runners to properly fill the part, but also to avoid and reduce the waste of cold material in the runners. Water circuits. When discussing a thermal system, a lot of decisions are made to place the water lines in the optimal locations. There are a lot of factors, including what is in the design that I need to work around. Lifters, slides, and components can make it difficult for ideal placement for the best thermal for this part. VISI can also design conformal cooling lines to have the ideal thermal in hard to reach areas. The water circuits are very important to avoid both deformation and also optimize the mold cycle time. Material shrinkage. Material shrinkage has a lot of factors. One of the most important, did I design the tool with the correct shrink value? With VISI, we have the utility body to mold that controls placing the shrink value into the actual solid model as an attribute. At any time within the design stage, you can query the model and see what the value is set to. Of course, the waterline design and the temperatures are a big factor in considering the proper shrink. There is also the injection press settings. That is a lot of variables to contend with. Fiber orientation. This is based on part geometry, runner design, gate location. Also, the fiber orientation can be different from the original part to the final part with warpage. Warpage. With all the factors of the design, VISI does have some unique tools to help with the warp data from the shape analysis. We have morphing tools that can manipulate the data to compensate the warp data. Also coming soon in the next release of VISI 2024.3, there will be an automated function, warp compensation, that can create a new model based on the original CAD and data from the shape analysis. Cycle times. The software can recommend cycle times based on the holding pressure and thermal, then create additional analysis to adjust some variables to affect the cycle times. It is very important to optimize the cycle times to get the most accurate part with the correct characteristics. This is probably one of the most important parts of the production. Considering all the aspects, we believe that the software is the key to improving the plastic part and the injection mold designs, as well as the whole manufacturing process, resulting in the design quality and accuracy of the parts, the very beginning to lower costs and future savings. How we measure the value of our plastic injection molding solution. Connecting to what we just said, how we measure the value of plastic molding solution, first, let's understand what is typical of the current process. Traditionally start by creating a concept part, followed by a prototype mold, and then manufacturing of the mold. In these cases, the testing phase sometimes reveals that some of the parameters are overlooked, and this leads to failure in some structures. Sorry about that. Our VISI FEA solution considers, during the designing process, all the parameters that enable the precise design of the components by showing how analysis may impact the design of the mold assembly. The overall gains are affordable with faster design cycle, improved design, insights into crucial design parameters, virtual prototyping, and reduced tryouts. For example, in this picture, how to dramatically reduce the cooling times using the conformal cooling for the thermal analysis, shown right here. VISI can also design the conformal cooling circuits from the mold module. The circuits can easily be added to the thermal analysis. Design and engineering, basic flow analysis. In addition to the complete flow module that we see later, in the mold menu, there are two entry-level commands available. They are for flow and thermal analysis, respectively called filling and cooling validation. Let's see how the filling module that has been greatly enhanced with the VISI 2023.1 current version works. As you can see, this is included in the mold design menu right here. Starting with the part definition, simply select your part, search the material database, assign the correct material. Next, create a mesh model of the part. Adjustments can be made on the fly depending on your part shape. Once this is done, let's make some thickness changes to these features. The software can change the assigned thickness to different values. This allows you to run an analysis and see different results without updating the CAD model. Opening the filling validation command, we can see VISI shows the parameters for injection time, melt temp, mold temp, and others. Now let's pick an injection point and run the calculation. Once the calculation is done, we can go ahead and view the results of different variables like isochrone, temperature, pressure, etc. Looking at the temperature settings in the filling analysis, we can view different quality templates to make some assumptions. Now run a calculation to show air traps and weld lines, which are displayed on the model. This helps for some design decisions. Click to display the graph chart, then show the filling with pressure. Properly orientate the model, orientate the part to the mold position to calculate clamping force needed for this part. All these are important factors and can be analyzed at the beginning of the process with just a simple model, as you can see on the screen, without editing anything else. But in this case, in this example, you can see if the thickness of the part is reasonable to have ideal cycle times, and if the filling with the selected gates are good or not. You can immediately start to avoid issues with this tool. Design and engineering, advanced flow analysis. Complete filling simulation with the setting of all possible molding parameters provides the ability to forecast and visualize how a component will be filled by the plastic melt front, making it possible to identify any potential issues. The VISI Flow module allows you to investigate the molding variables such as pressure, temperature, shear stress, frozen skin, fiber orientation, clamping force, many others. Now let's display the part mesh and runner from flow analysis. As you can see in the model preparation window, this is where we add and change our data for analysis. After running the thickness calculation, we can immediately change the thickness of local areas to meet our needs or test out different part thicknesses. Without modifying the actual CAD model. This
Hello, everybody. Bear with us for a second as we try to figure out these technical difficulties. Sorry, but so William, you conked out there for a little bit.
Oh, did I?
Yes. You can keep going.
Hold on. Can you hear me now?
Yep, we can hear you.
Okay, let's jump. Okay, let me stop the video. Let's go. Let's back and go through again. Okay, going again. Let's skip up to, this is going back through the thickness calculation and how you can assign the thicknesses. And once we're done with that, we'll go over to displaying your runners, gates, and then how I can modify or add different types of gating and different run systems into the product, all by filling out these different parameters. And once this is done, this is where you can add a hot tip and define runner gate assembly. And I'll jump analysis tab. The settings in the molding data window are very simple to use. The software guides you with suggestions from the assigned material. The variables on the molding machine, when molding a plastic part, pressure limits on the opening force. On the advanced tab, configuring sequential molding is included with the options shown here, which I can set the valve pin timing also. After running a calculation, which is very fast, we can display many results. We can easily read, for example, the isochrome and how it'll show the parts filling. Displaying a graph chart, we can show the pressure required to fill the part. By reviewing the crucial areas and evaluate the quality of the mold to obtain operational suggestions. Dragging the ball on the graph will show the filling simulation and the pressure at each point on the graph. Opening the quality settings, just pick one of the quality templates listed. We can see the temperature and shear stress are slightly out of limits. The program is suggesting to reduce the ejection speed. In this case, we can evaluate the shear stress with the picked quality template as shown in this area, shown over here. Analyzing the temperature to understand the quality at the locations. In this case, we could see the weld line here, right in here. Turning on the display of the fiber orientation, you can visualize how the flow is moving towards the weld line on each side. We can check the temperature on each side of the weld line. This could be the cause of the weld line based on lower temperature in this area, causing the material not to melt together. On the temperature variable, let's review what is going on through a section of the part. By clicking on the section icon and picking a direction to cut the section, we can investigate some variables within the section. Let's check out shear stress with a picked quality template within this section. With the analysis of the holding phase, we can predict cycle times based on cooling times. This is informative when calculating another analysis. It is very important to understand the cooling time of any area on the part. For example, by adjusting the scale, you can see the cooling times graphically and compared to your original settings to make some decisions. Make sure the part is solidified is important not only for cycle time or to understand how the cooling system is affecting the process, but knowing if the part is ready to be removed from the mold. In this case, as indicated, it is a major confirmation of the solid fraction. By selecting some elements, we can review the temperature, which should be lower than the solidification temperature. The program shows a line indicating the freeze temperature within the graph. It helps you to understand when you have reached this moment on an element. In this case, the one selected here is completely solidified. It is worth mentioning that all these modules allow the customer to grow according to their needs, starting with the basic modules, included with the mold module, and then grow into using the complete filling analysis with runner gate definition and cooling line definitions. Then into packing analysis, holding, and then warp analysis, lastly to the thermal analysis. Design engineering smart cooling channels. Before diving into the thermal analysis of the mold, it is worth emphasizing once again the integration between various modules, which allows for better operation without loss of any data. The mold design module permits easy insertion of cooling lines through a wizard that allows the designer to fully control the position and size of the cooling lines. After selecting a detail, you will need to decide the direction in which to add a hole. Once confirmed, the model will orientate itself accordingly to allow easy insertion of channels. After the application point is selected, the application switches to another direction to complete the first channel. Then we complete the first circuit by selecting the positive X direction for the through hole between the two holes just created. It is possible to ignore the collision messages, but you should check it out afterwards. It is possible to manipulate the cooling lines using the standard VISI transformation command. During the insertion of water lines, water fittings can be easily inserted from major supplier libraries. A comprehensive set of editing functions allows you to control every detail of the cooling system. So very quickly, you can sketch some cooling lines to create a simple circuit. Thermal prediction. Now we're ready to show you the thermal analysis using VISI Flow thermal module, which can be used as a standalone analysis. So if you just want to do thermal, you could just use VISI thermal to create some information for your water circuits. If the cooling system has been designed using VISI mold cooling commands, as in this case, it is very easy to pass the information to the flow analysis environment, thus drastically reducing preparation times. This utility allows you to verify the circuits. The representation of cooling lines are passed directly to the flow module, where the dimensions of the channels can be changed on the fly without having to modify the CAD model. In this video, we'll begin by showing the cooling module first, then showing thermal analysis. Let's check out the water circuits on this core block. Opening the cooling module, just select the circuits that you want to send to the flow analysis, which is very easy. Right here. Simply pick the in and out lines and then add some information to each circuit following the prompts in the filling in the parameters for each of the water circuits. You can always define the baffles as shown here. Just select from the list and add the parameters. Then pick the next baffle until they're all updated. Once done, a message will confirm that it was copied and ready for the flow analysis. For example, in this case, we passed all this information, including the baffle information, into the flow analysis module. Once the circuits are passed to the flow environment, they can be configured in additional analysis with different parameters. Just change the properties of any of the water lines without having to go back to the CAD system and change the design. This is really a great feature for testing different scenarios. If the model came from another CAD system, there are two tools available, one for the feeding system, runners, and the other for the cooling channels, water, to quickly pass this geometric information to the flow environment. In this example, we will use the cavity block to simulate coming from another CAD system. Just using the draw coolant channels, we can analyze and define cooling channels from the solid block, just like shown here. Now that the cavity and core circuits have all the information assigned, using the VISI modeling system, just display the part mesh and show the cavity and core water circuits. Making sure to check out the circuits and look for any issues before continuing forward. Quickly check the circuits to see if they are properly connected to avoid issues when formatting for analysis. When the mold is ready to be formatted for analysis, just click on the format icon to run the calculations. Other checks are performed by the software to avoid any issues. Everything is done automatically. Let's create a thermal analysis. The input of the calculation data is very simple. Just choose the plastic material and define the material of any mold details. Open the water circuits window by clicking on the icon. Then the water circuits are presented to the user with many options available. You may choose to connect multiple circuits together, like a jumper hose, or remove a circuit, or reverse a circuit, or change any parameters in this window. The program will also suggest the optimal value of the flow rate of the water based on the assumed cooling time. The calculation of the cycle can be set based on experience or left to the software in reference to the cooling of the desired area of the piece. Upon reviewing more parameters under the molding data tab, we can set the cooling time to a fixed value by clicking on an element on the model. Note that the block containing the inserts and the cooling circuits can be meshed up to 40 million triangles. This provides very detailed, sophisticated analysis. So now we're ready to visualize the results, reviewing the temperature of the plastic material at the end of the fill with the solid fraction variable. It is important to know the part can be removed. Equally interesting is the distribution of the surface temperature of the mold, which in this case, there are some visual differences between the cavity and core part of the mold. Remember that such non-uniformities can lead to the deformations of the part. Therefore, optimization is very important. To better understand and evaluate the efficiency of the cooling system, it is possible to cut dynamic section through the mold. We can choose a direction in the mold block, turn on multiple sections, look from any point of view, display the displaying of the cooling channels and baffles to help us evaluate if the cooling lines are performing per the design. Dynamically drag the section, or you can animate by clicking on the play button, shown here. So dragging the section through or just hitting the play button and let it do it automatically. Using the VISI layer system, displaying the different details of the mold within the section view of the thermal analysis can help to understand where the details are located. This is why any shop owner, designer, mold maker, and even a molder are looking for another great tool in their toolbox. This tool helps to quickly analyze and make decisions based on the results. Finally, as indicated, the thermal analysis can be carried out on its own or integrated with the flow analysis to obtain a more precise calculation of the final deformation of the part. In this case, after running a filling analysis that would be followed by a warpage analysis, we can integrate the results of the thermal analysis shown here. Warpage estimates compensation. The final molded part is closely related to the conditions generated in the mold cavity during the cycle time. Warpage results allow you to visualize and measure the final molded shape predicted after the molding phases. Many tools are provided for evaluating the process, including viewing, displacement along an axis, linear shrinkage, and measure of features. In addition, the morphing tools can deform the geometry while maintaining mold integrity to easily modify, compensate the insert's geometry. In this video, looking at the flow shape module, there are many possibilities to visualize and understand the deformation due to molding process. We can visualize and animate the deformed part, saving it to a layer or into an STL format to eventually export to another system. Thanks to the full integration with the CAD environment, the deformation can thus be easily compared and measured with respect to the original model. In this example, the gray part is the original model, the yellow mesh is the deformed part. To help us see, the part will deform using the slider bar to magnify the deformation of the part. We can evaluate the direction of the shape of the part and make some decisions on how to proceed, saving it to a layer for additional functions in VISI or exporting the file to perform external analysis with one of Hexagon's CA suite of products. Using VISI fully integrated environment software, we can simply select the parts and measure to have a comparison. For example, cutting a dynamic section of both the CAD model and warp model, then create section lines through both parts. Now using the query command, just clicking on 2 points, we have the results of our differences. This is what you can do with a complete all-in-one system. The effects that led to the total deformation can be evaluated separately. It is possible to visualize these displacements of each node along any direction. Finally, various measuring tools are available, such as the evaluation of linear shrinkage in a certain area of a part. For example, we can measure the linear shrinkage from a node to node. We now have this information of the nominal dimension and the final dimension, including the linear shrinkage value, as shown here. All the tools are available and integrated into one environment to run these evaluations. Why is the ability to control warpage so important to mold makers? This part shown in the picture has a very high shrinkage. The shape and dimensions of an injection molded part are closely related to the pressure and temperature and other thermomechanical properties of the material in the mold during the process cycle. Industrial demand for high dimensional stability, excellent visual appearance, and accurate fit with mating components requires that defects caused by warpage should be performed when designing the injection molded parts, possibly at the very beginning of the process, but also checking it after the production part. An accurate shrinkage and warpage prediction can identify excessive shrinkage or warpage might occur to help the optimization of the part and mold design, including the material choice and processing parameters. This video will demonstrate the power of VISI morphing tools after running a complete filling analysis. This will show how powerful the VISI morphing technology can be when applied to a plastic part. In fact, after the calculation of the deformation of a nominal model with our VISI Flow application, using the Warpage module, the part can be compensated. Upon reviewing the data in the model preparation window, we can see the results of the thickness calculation on this part. Now let's review the results of our flow analysis, opening the analysis window. Load the results of the filling analysis to review. The gate is on the backside center top part, and you can see how it is filling through this part based on the gate location. Open the results of the warp analysis. Now let's look at the warpage of this part. This is how the part warped due to the molding conditions. We can magnify the results to better understand the direction of warpage. If needed, we can save to a layer or export to a file. Getting ready to use VISI TDD, overlaying the part model and mesh warp model, we can easily see the differences here. By creating some curves in these areas from both models, we can start to prepare for using VISI TDD morphing command. Open the morphing command. It is very easy to follow. Just start at the top and work your way down. Let's start. Pick the part to modify. This is the original part model. Now pick what to preserve. The last step will be to pick the from line and to line for one of these features. Just like they're shown here. Once done, add another step in the tree for a second from and to group and repeat the steps for the other feature. Clicking on the preview button, you can see how quickly it created a new compensated geometry. Once you are done, just click on the green checkbox at the top to confirm. Now you can see the original model, the warped mesh, and now the newly created solid model. That fast. This is a powerful tool that will dramatically reduce time and save money when modifying parts for warp compensation. Let's point out that what we have seen using TDD in this video has been fully automated in the new upcoming version of VISI 2024.3 using a new command called Warpage compensation available in the mold design module. Let us summarize what we have seen so far for this phase of the process. Typically, VISI customers are Tier 2 and Tier 3 and receive data from a Tier 1 companies. VISI can import any data to create designs and analyze the information. In fact, VISI offers a complete solution to create, edit, or repair complex 3D data. As we have seen, all the areas of the molded component creation can benefit from the optimization of the mold tool design and the molding process parameters. VISI Flow is a unique prediction tool ideal for production, post-production analysis, and concurrent engineering of injection molded plastic parts. This is a list of the possibilities provided by the software that range from automatic modeling of the part, which cuts model preparation calculation times, to accurate filling, simulation, warpage prediction, and engineering of the mold water system. Fully automatic solid model transfer from CAD environments, short model preparation calculation times, ability to import feeding and cooling systems, scientific analysis of the melt flow behavior into a mold cavity, accurate filling simulation with identification of aesthetic issues and evaluation of temperature, pressure, clamping force, and many other fundamental variables. Runner optimization, material database customization, warp prediction, fiber orientation, engineering of the mold, thermal conditioning or water system. VISI Flow thermal mold tool design optimization. Finally, let's summarize the main points of what was discussed. VISI Flow analysis is beneficial for optimizing mold tool designs and molding process parameters. The technology assists part designers, mold makers, and molders to achieve cost-effective, reliable mold designs, along with optimal molding conditions. VISI Flow is a unique prediction tool, perfect for both pre-production, post-production analysis. VISI Flow helps for design planning, as shown in this example in the upper right-hand corner, to predict the part filling and where the possible air traps are located. Helps to plan where to add venting into our designs. This pre-planning helps to avoid building prototype tooling and experimenting with the tool to build a production tool. Lastly, facilitates concurrent engineering of injection molded plastic parts. Final part shape. VISI's Warpage, the final part shape control. The shape and dimensions of the injection molded part are associated with the pressure, temperature, and other thermomechanical properties of the material during process. The ability to manage these variables is very important because of any of these can have an impact on the final part. High industrial demand calls for dimensional stability, excellent visual appearance, and accurate fit of corresponding components. Injection molded parts should be designed keeping in mind the potential warpage-related defects. Accurate shrinkage and warpage predictions help detect excessive shrinking and potential warpage. As shown in this example, To the right, the final part measurements compared to the flow analysis. This can show if the predictions are in line with the nominal part dimensions. These predictions facilitate optimization of the part, mold design, material selection, and processing techniques. VISI Warpage morphing in action. As a final demonstration, we would like to illustrate how morphing technology available in the VISI modeling can be applied to real molds to achieve valuable time and cost savings during the part and tool design by correcting the warpage due to the molding process. Speaking of synergies between Hexagon products, we can import a volume graphics digital model coming from a CT scanner. Let's check out this last video showing TDD can be used on tooling. This part, a handle of a vacuum cleaner, is from our colleagues at Volume Graphics. We can explore the surface compensation techniques available in VISI using the target-driven deformation technology known as TDD. Just like before, fill in all the required parameters to set up for using TDD. It could be points, lines, curves. If the preview results look good, we can confirm the compensated model. When we are ready to extend what we just saw on the part to optimize the mold, let's display the cavity insert we want to modify. Create the curves from the newly updated part model and create the curves on the cavity. Add some points where needed using TDD to directly modify the geometry of the insert. What we saw in the parts can also be done to modify tooling. So once we're done picking everything we want, we can go ahead and preview it. Once the preview is shown on the insert, just confirm the insert modifications. See the results of the inserts are now updated. We can also edit the standard components, in this case, the ejector pins, to update the newly modified inserts. This is another powerful functionality available in VISI. Not only can VISI adjust parts, but also tooling. So I thank you for listening to me during this presentation and wish you a good day. Next up, Q&A.
All right, thank you, William. All right, we do have some questions, but before we jump into any, I want to make sure everybody listening knows there's plenty of time to ask questions. So just type them into the Q&A tab on your screen, and we'll get William to get through as many as we can in the next 15 minutes or so. I also want to mention, in case William has not, that there are handouts at the handout tab. So for further reference, did you want to talk about that at all, William?
Yeah, we can. We have several handouts that are available. VISI brochures, the whole process of the molding to manufacturing process of a plastic injection molds. And I think there's several others up there, but yeah, worth reading for sure to find out if this is something you guys need in your companies.
All right. Okay. Let's get started. All right. So does the VISI Flow software support simulating filling with hot runner manifold systems with valve gates?
So, answer is yes, we do. During the preparation stage, all the parameters for size of a hot drop, runner sizes, and the size of the valve pins can be configured. During the filling analysis, there are settings for when you need to open and close the valves. This can be based on time, or it can be based on picking a triangle where you believe the flow should reach before I open the next valve pin. So the answer is yes, and that's how we can configure it.
All right. Let's see here. Can we have multiple analyses, different settings within the same project?
Yeah. So what that's really, that question I believe is, so if I ran let's say for instance, I did a filling analysis and I had some certain settings in there for mold temp and melt temp and maybe injection speed, I can easily copy that data as another list in my filling analysis and make any changes I want to, and then recalculate that. So now I have two different filling analysis, and this applies to all the different analysis, but this, for example, is how you can compare to know if I'm going in the right direction. And this is just common practice of what you would do to make sure I'm going down the right path.
Okay, great. How many different resin grades are available in the software database?
There's, I know I don't have an exact number, but there's
come on.
Over 10,000 for sure. It's a lot. I mean, VISI is always updating their material library for different plastics. You can even in the material library, a user has full control to make copies of what's in the database to a user database, and then make adjustments depending on what they believe they need to do. And you can actually add your own material in there. If you have a supplier that is newer and you want to work with them, they can send you the data and you can add everything into the database yourself.
Good answer. All right. Could you please expand a little more on the methodology that you follow for the compensation through TDD?
Yeah, so that's great. So TDD is a really strong morphing command. So what it allows you to do is take, in the instance of plastic injection molds, take the warp model, which is bent, right, or deformed out of the position of the original CAD model. And it allows you, there's tools in the TDD that allows you to either manually, I can cut sections through both, I can manually manipulate the section if I want to, and not just section lines, I can use points also. So I can do this manually and actually bend the part the way I want it from freehand. I can also, there's actually a compensation module with the TDD that allows you to pick points on the CAD model, project it to the warp model, and then have both sets of points run a compensation that you overcomp it, and by using those 3 points, I can actually bend the model the opposite way, which in the plastic industry we call windage.
Yeah.
And go ahead and run another calculation based on that. Does that make sense?
Does that make sense to the one out there who asked the question? I'm sure it does.
Good.
If not, I'm sure they'll add more in there. Let's see. All right. Can VISI Flow handle a complex runner and gate system within a family of parts that are unique?
And the answer is yes. So by designing the family parts, which could be different weights, which typically it might be, your runners are based on each part having maybe a different size runner going to it and all that. As you assign it in the model prep, you basically load the whole thing in as one solid model, convert it to a mesh, and then you can simply select the triangles that create the gate and runner, and it defines it as gate and runner, so it knows that when it does the analysis that it can check for a gate freeze if your gate's too small and report back to you if the gate will freeze. So yes, the answer is yes, you can define complex family parts with multiple runners.
Got it. Okay, some customers ask if the software will suggest to the mold designer the injection point.
So unfortunately, no, because we rely on experience.
Okay.
We believe the mold shops are the experienced people. They have molders that are generally on staff. And they will give you the best suggestion based on material and gate position. Now, if you're designing your own part from scratch on your own, maybe you're wondering where to put that gate. Right. And by using our in the mold module, the filling analysis, which you can quickly pick a point run an analysis, see how they reacted, and then quickly just make a copy, pick a different injection point, and see the results of that. So we don't suggest, but you have the tools in front of you to quickly see how the part's going to fill for you.
Can VISI Flow designate the material of the mold for the thermal analysis?
Yes, the answer is yes. I have a library of materials for the components. Very simple. I can, if you had mold inserts and one's a steel insert and one's a mold max or beryllium insert, I can actually assign those different materials, and you can actually see the different temperature ranges from those analysis.
Okay, we still have time for people. We had quite a bit of people on the line listening to you, William, so there is still time to have some questions.
Nice.
Sometimes people can be a little shy and they want to follow up later. So William's contact information is up on the screen. You can see his email address, so feel free to contact him directly. Is there anything in particular that, I guess I would say, if people aren't asking, are there particular misunderstandings or things people don't get that you want to run through about the software?
All I want to say is, VISI is an easy, free-form, solid modeler for mold, was specifically built for mold designs, and has all the tools from start to finish, not even in the mold design arena, but I can actually do manufacturing. So it can, if you're looking for a software to help you perform faster, we can help you through the whole process. So VISI is an all-in-one design, flow analysis, modeling, compensation through manufacturing of CNC machines.
One and done. All right, do you have another question? Is it possible to do a core shift or mold deformation calculation?
Yes, so the last slide I showed actually took the part after we ran and deformed the part that was the vacuum cleaner handle. Once that was done, we actually went and deformed the new parting lines on the core insert to that new part. So yes, you can definitely use the morphing tools to manipulate the tooling also.
All right, I'm going through the question pane. All right, looks like we answered all the ones on there. Are any final takeaways from you, William, outside of what you said?
I would say, hey guys, it's a fast, easy software. Give me a call and we can actually sit down and, we can schedule a demo and show you how it all works.
All right. Well, thank you, William, for your time and for the presentation this afternoon and for answering all those questions. And for those listening, check out the handouts, contact William through his email address on the screen. Thank you, Kylie, for organizing, helping this run smoothly. And thank you all for listening in. Lastly, visit moldmakingtechnology.com for this webinar and all archived webinars. Again, I'm Christina Fugis with Mold Making Technology, and this concludes today's webinar. Have a great rest of the day.